Why interested in AdS CFT correspondence in 5 minutes? Different sized objects are being described by different physical theorems. Physicists use quantum mechanics to describe tiny things like electrons or quarks, while use the gravitational theorem to describe huge objects like the sun, black holes, or the whole universe. Those two theorems seem so different from each other, but they are actually related by some hidden links. AdS-CFT correspondence is one of those links. The full name is called anti-de Sitter space conformal field theorem correspondence. The anti-de Sitter space lives in the world of gravity, while conformal field theorem lives in the world of quantum mechanics. It describes that some quantum systems are the same as one more dimensional gravitational systems. Suppose we have two quantum squares interacting in the quantum world. That would be equivalent to two cubes with gravitational interactions under this AdS-CFT correspondence. To learn more about this correspondence, we need some more details about the anti-de Sitter space. De Sitter and Einstein firstly proposed the idea for anti-de Sitter space while they were considering about possible structures of the universe. In total, they proposed 3 possible structures of the universe: the de Sitter space, which is an analogy to a sphere; the Minkowski space, analogized to a flat surface; and the anti-de Sitter space, analogized to a hyperbolic. One can understand those universes as follows. Suppose you had a friend, Bob, decide to travel around those universes. In a de Sitter space, while Bob traveling further, the size of Bob you measured would become smaller. In Minkowski space, the size of Bob will not change no matter how far he's traveling. And lastly, in the anti-de Sitter space, the size of Bob you measured expands while traveling away. But how might that connect to the quantum mechanics? The key to this question is the physical concept called the renormalization scale. Renormalization scale can be understood as the level of details we work under while studying a physical system. Suppose we use this stick figure to represent the quantum system we're studying. Different renormalization scale would be represented by the same stick figure, but with different resolutions. The smaller the renormalization scale gets, the more pixels one picture has. Thus, more details are being considered for that picture. Now, if we make the size of pixels in each diagram the same, the size of each stick figure would change according to how much pixels they have. If we make this process continuous and order them by how many pixels they have in each diagram, that will recreate exactly what we described for the anti-de Sitter space. Now one might ask, why not just work with the stick figure we had in the first place directly? That's because information encoded in quantum mechanics is dense and hard to interpret. In reality, rather than the oversimplified stick figure, a DVD is more like how information is encoded in quantum mechanics. Technically speaking, all information in that disk has already been written on the back of that. However, when someone said they want to watch that disk, they will not just pick it up and look at it. What they will rather do is that they will plug that disk into a player, connecting that to a TV, and watch the image shown on that TV. The AdS-CFT correspondence just did the same job as that player here. It translates the incomprehensible quantum disk into an understandable gravitational image. Now, let us talk about the usage of AdS-CFT correspondence. One main usage is in the study of hydrodynamics. Swimming pools or the waves might be the first thing people think about when mentioning the hydrodynamics. However, hydrodynamics is more than that. For example, for an airplane flying in the sky, hydrodynamics describes the airflow around that plane. And for a nuclear fusion station, hydrodynamics describes how the plasma behaves. AdS-CFT correspondence is a handy tool when it comes to the calculations for hydrodynamics. For example, I studied the univalence property for hydrodynamics using AdS-CFT correspondence for my AMPHIS project. But what's more important about AdS-CFT is the physical understanding it provides. For a very long time, physicists have been working on unifying quantum mechanics and gravity. Although AdS-CFT is not enough to answer this ultimate question, it is indeed one of those secret links. Therefore, if we could understand the AdS-CFT better, it would provide us with new pieces to build up that ultimate theorem. And if one day we manage to find enough pieces, we might finally be able to answer that question and find the theorem for everything.